Hello student, I am back again. Today we are going to take up a very important topic and very important topic with respect to your entrance exam, and that is states of matter. So we are going to see some very important questions and very interesting also. So let's begin with the first question itself. The ratio of masses of oxygen and nitrogen of a particular gaseous mixture is 1:4. The ratio of number of the molecule is 1:4, 7:32, or 1:8, or 3:16. Now will you solve this question? Very simple. Very simple solution for this question. What you do is, you take the ratio of moles. Take the ratio of moles. So N stands for mole. So mole of oxygen upon mole of nitrogen. Now we all know mole is nothing else but mass of oxygen upon molar mass of oxygen divided by mass of nitrogen upon molar mass of nitrogen. So now this is division. So when you do multiplication, it will go up. So it is mass of oxygen upon mass of nitrogen into molar mass of nitrogen upon molar mass of oxygen, which gives you the mole of oxygen upon mole of nitrogen. Now substituting the value which they have given us, mass of oxygen and nitrogen is given at 1:4. So this is 1/4 into, what is the molar mass of nitrogen? Molar mass of nitrogen is 28, everybody knows. See, N is 14, N2 will become 28. So this is 28, 1O is 16, so O2 will be 32. So it is 28/32. Now just cancel it. 4 1s are 4, 4 7s are 4 7s are 28. So therefore mole of oxygen upon moles of nitrogen is 7/32. This is your answer. But just now we have taken mole. This mole can also be called as molecule, because moles is nothing else but, for molecule we multiply by Avogadro's number. So on the top also and down also, so it will get cancelled. So either we say mole or we say molecule, will be one and the same in case of this ratio. So your answer is 7/32. So your answer for this question is B. Now let us see one very interesting question. That is, two vessels containing gases A and B are interconnected as shown in the figure. The stopper is opened, the gases are allowed to mix. The partial pressure of A and B is. So now you need to find out partial pressure. We know that partial pressure is the product of total pressure into its mole fraction. So let's see step by step how will you go about with it. So let's see the solution part. Now for gas A, vessel A, take out the mole of gas A. So N is the mole of gas A, which is equal to pressure into volume of A divided by RT. So now, what is the pressure given in the first case? 8 into volume. What is the volume given to you? 12 upon RT. So this is 96 upon RT is the mole of A. Mole of A, gas A. So gas A, the mole is 96 upon RT. Now let us see for gas B. Gas B, the mole of gas B will be equal to pressure of gas B into volume of gas B upon RT. So now, what is the pressure given? 5 into, what is the volume given? 8 upon RT. This is 40 upon RT. Now, you got the mole of A, you got the mole of B. Now, let us see the total pressure now. Okay. So, total pressure is equal to, if I want total pressure into total volume will be moles total into RT. Okay. So, pressure total will be equal to, what will be the total volume? 12 plus 8. 12 plus 8 liters will be the total volume. What will be the total moles? Total moles will be 96 upon RT plus 40 upon RT into RT. Okay, now we just need to solve this in order to get total pressure. Now when you solve this, the total pressure will be, this will be 20, and in this case RT gets cancelled. So 96 plus 40 will give you 6, 136. So what will be the total pressure? Is 136 divided by 20. So this will be 6.8 is the total pressure. 6.8 is the total pressure. This much atmosphere is the total pressure. But you want what? Partial pressure. Okay, you want a partial pressure of A and B. So, partial pressure of A will be equal to total pressure into mole fraction of A. So, total pressure is 6.8 into mole fraction of A. So, mole fraction of A, for that you have moles of A, that is 96 upon RT upon total moles, which is 96 upon RT plus 40 upon RT. Now, when you solve this question, you will get 4.8 atmosphere is the partial pressure of A. This much atmosphere is the answer for A. Now, partial pressure of B. Partial pressure of B will be total pressure into mole fraction of B. Now, total pressure is 6.8 into mole fraction of B is mole of B, that is 40 upon RT divided by the total mole, that is 96 upon RT plus 40 upon RT. Solving this, you get 2 atmosphere. So the partial pressure of B is 2 atmosphere. So your answer for this question is C. C is the answer for this question. Let's see one very simple question which might be asked in your exam. That is, Dalton law of partial pressure is not applicable to. Now this is a direct question. You know, Dalton law of partial pressure is applicable to non-reacting gases. Non-reacting gases in a mixture. If the gas react among themselves to give you a new product, then it is not following Dalton law of partial pressure. So let's see the options. First is O2 and O3. They don't react with themselves, nor CO and CO2. What about ammonia with HCl? Yes, ammonia will combine with HCl and it forms ammonium chloride, which is a sublimate compound. Ammonia gas combined with HCl gas giving you solid ammonium chloride, which undergoes sublimation. So these are the two gases which is reacting. So Dalton law of partial pressure is not applicable for those gases which are reacting among themselves. So your answer for this question is C. Let's see this question. It is similar to what we had done in a previous case. Calculate the total pressure in a 10-liter cylinder which contains 0.4 grams helium, 1.6 grams oxygen, 1.4 grams nitrogen. They are all non-reacting gases at 27 degrees Celsius. Remember, temperature should be taken in Kelvin. So 27 degree will make up 300 Kelvin. So you require the total pressure. Now, how will you solve this question? So first and foremost, you take out the moles for all these gases. So moles of helium is mass given upon molar mass, that is 4. So it will be 0.1. Then mole for oxygen will be 1.6 divided by 32, that is 0.05. Then moles of nitrogen will be 1.4 divided by 28 molar mass. So it is 0.05. Okay. Now total pressure into total volume will be equal to total moles into R into T, where T is temperature. So now just substituting the values, I require to find out total pressure. Total volume is given as 10 liters is equal to, now add these moles, total moles will be 0.2. So this will be 0.2 into 0.082 is the value of R, and temperature should be taken in Kelvin, so 300. Now you just need to solve this question. So total pressure will be 0.492 atmosphere. So your answer for this question is A. A is the correct answer for this question. Okay. So let's now go for one more question. The ratio of the rate of diffusion of helium and methane under identical condition of pressure and temperature will be? A very simple question actually. Now we know that under identical condition of pressure and temperature, the rate of diffusion of helium and rate of diffusion of methane is equal to square root of molecular weight of methane upon molecular weight of helium. Now substituting the values, the molecular weight of methane is 16 and that of helium is 4. So it will be root of 4. So the answer is 2. Okay, so the ratio of it is nothing else but 2. 2:1. That is 2 is your answer for this question. C is the answer for this question. Let's see a practical oriented question. The question says two gas, ammonia and HCl, are introduced simultaneously from the two ends of a long tube. A white ring of ammonium chloride appears first. So they are saying there is a tube, a long tube, and from one end you are introducing ammonia and from the other end you are introducing HCl gas, and we all know when they are going to mix they will turn into ammonium chloride. That's what they want to know. Where is this ammonia chloride formed? Is it closer to ammonia or is it closer to HCl or is it going to be in the middle? Now this is very simple question actually. Now what you do is you take out the molar mass. We all know the molar mass for HCl is 36.5 grams, whereas ammonia, the molar mass of ammonia is 17. Now tell me, which one is lighter, ammonia or HCl? Definitely HCl is heavier, ammonia is lighter. So the movement of ammonia gas will be faster. So it will move very quickly as compared to HCl. So ammonium chloride will be formed more closer towards HCl because it is heavy, heavier than ammonia. So your answer for this question should be nearer to the HCl end. Answer should be A for this question. Let's now see this question. It says at 400 Kelvin temperature, the root mean square speed RMS, root mean square speed of a gas X of molecular weight 40 is equal to the most probable speed MPS of a gas Y at 60 Kelvin. The molecular weight of the gas Y you want. Now they are saying that the speed, root mean square speed and MPS are equal. That means RMS is equal to MPS. Now we all know RMS is given by root of 3RT upon molecular weight of gas X, and this MPS for gas Y is 2RT upon molecular weight of Y. Now R and R are same, so that will not be counted. The next will be temperature for X is given as 400 Kelvin and the molecular weight of X is 40. Molecular weight is 40. Whereas for Y, the temperature given is 60 for Y and molecular weight we need to find out. Now what you need to do is just solve this question and get the molecular weight of Y, which will come out to be 4. So the answer for this question will be B is the correct answer for this question. Okay student, a very important question now. If Z is the compressibility factor, then the van der Waals equation at low pressure can be written as Z is equal to 1 plus RT by PV, Z is equal to 1 minus A upon V RT, Z is equal to 1 minus PV upon RT, or Z is equal to 1 plus PV upon RT. Now how will you solve this question? This question needs to be tackled step by step. So let us see this question and let's see the solution for it. How to go about with the solution for this question. Okay. So first of all, what is van der Waals equation? Van der Waals equation is given as P plus an square by v square into v minus nb is equal to nRT. This is your van der Waals equation. Now for 1 mole n value will be 1. Now the equation will become P plus A upon V square into V minus B is equal to RT. Okay, now since it is very low pressure means volume very large volume, pressure is low, so volume will be large. If volume is large, then V minus B is taken as V only. V minus B is taken as V. So substituting here, so P plus A upon V square into V will be equal to RT. Now open this bracket. So it will be PV plus A by V will be equal to RT. Now take this on the other side. So PV will be equal to RT minus A by V. Now very interesting. Divide by RT. Divide by RT. Now when you divide by RT, you will get PV upon RT will be equal to 1 minus A by VRT. Now this is very interesting. Look at this equation very carefully. Now we all know for ideal gas we know PV is equal to ZRT for 1 mole. So PV upon RT is equal to Z. PV upon RT is equal to Z. This I can take equation 1. this I can take equation 2. Therefore, Z will be equal to 1 minus A upon V R T. So this is the relation for compressibility factor, where Z is the compressibility factor. So looking at the option, your option B is correct. Let's see this question, which is based on the previous question we had done it. It is similar to it. The term that corrects for the attraction forces present in a real gas in the van der Waals equation is. So we already know the van der Waals equation, which is P plus A n square by V square, V minus NB is equal to nRT. Now they are asking you the term which tells you about the attraction forces. So in case of van der Waals forces, the attraction forces which is accounted is this term, that is A n square by V square is the term which indicates the attraction between the intermolecular forces. The intermolecular forces which is occurring in it. Okay. So your answer for this question is B. Yes, student. Let's see this question, which says, which of the following will increase with the increase in temperature? Is it surface tension, viscosity, molality, or vapor pressure? Surface tension and viscosity, they both decrease with increase in temperature. So there is no question of these two for increasing. Molality is number of moles divided by the weight of the solvent in kg. So it is independent of temperature. It is not depending on temperature. The last is vapor pressure. Yes. As the temperature will increase, so do the kinetic energy also increases. If the kinetic energy increases of the molecule, they will leave the surface and go out as vapors. So the vapor pressure will increase with increase in temperature. So the answer for this question, your option is D is the correct answer. So with that, we have seen the various types of questions which can be framed from this topic, and I believe all of you must have understood this. So in the next lecture of mine, we'll be seeing some new topic with some new varieties of question. Till then, remain safe, be happy, and start working very hard for your competitive exams. Okay, see you all in the next lecture.